So we have three types of fundamental networks. We have the multi-layer perceptron. Multi-layer perceptrons are sufficient for tabular data. So if you have an Excel sheet with 5, 6, 7 columns, and you want to do regression or classification, you can create an MLP. And it's very trivial to create an MLP with libraries like PyTorch and TensorFlow. If you're going to be dealing with images, especially images of 3 color channels, then you will use a convolutional neural network. Again, the word convolution has to do with this matrix operation. In a convolutional network, we have 2 types of matrices. The matrix representing the picture, and the matrix, which is the kernel, which is used to, for lack of better words, to observe the superpixels of the picture. I think we've seen this before. I think I've shown you a kernel, but not. We will look at it in one of the sessions where we will use CNN for image recognition. And then there's a recurrent neural network. Long story short, you would use MLP if you have simple tabular data. Everything is numerical. CNNs if you have, square matrices, anything that needs to be put in square matrices, like a picture or videos. After all, videos are a sequence of pictures. And RNNs if you have sequential data for time series, for speech to text or text to speech, for sentiment analysis. By the way, if any of you are interested in predicting stock prices, it's very problematic because something you really can't do. But besides, if you're interested in, buying and selling stocks, well, the price of a stock is strongly influenced by public opinion. And so there are some companies that use sentiment analysis to see what people are saying about a certain topic. Like, what was that stock? GameStop? GameStop, right? And people would, what was the word they were using when they were on Twitter? Opposite of short selling. Opposite of shorting. Longing, right? They were trying to long the GameStop by showing, people were talking about the old Nokia or old, electronic forms of entertainment. And so they were making the price go up. So as people, basically you could use sentiment analysis to see, are people's sentiment positive about this topic? The price is going up, let's buy it. If people are saying negative things, let's say, I don't know, the CEO of this particular company said something very terrible, something very racist or sexist or whatever, and the prices are going to drop. And so you can use sentiment analysis to detect that and then start shorting or start selling. Exactly, Ron. So now, of course, getting access to the data is another story. Then a bunch of nerds started buying this stock. Exactly, yeah. As to retaliate. It's a very fascinating story. But yeah, my point is this. Without going too off topic here, if you want to process sequential data, like anything to do with time or words or sound bites, you want to use RNNs. But of course, like I said, we can combine. Like for one problem that I'm working on, I'm using a DRNN, which is a combination of convolutional networks and recurrent neural networks, because what I want to do is go from pictures to a sequence of characters. Basically, I think I talked about this. I want to look at a picture of an equation and convert it to a LaTeX code, which is a sequence of characters. Yeah, and thank you, Ron, for sharing the background of that GameStop scenario. So yeah, with sentiment analysis, you can see what people are talking about and then react preemptively. Okay. Now, the rest of this slides have to do with the mathematical representation. Here's an example of us using a CNN for pictures. So for example, you take this picture of a cat, and this picture of the cat is colored. So you have at least 3 color channels, red, green, and blue. And each channel will be put into its own matrix, which we call a 2-dimensional convolutional layer. It's called 2D because we have 2 dimensions for each color channel. And it's called the convolution because we're going to convolve the kernel with each color channel. Now, I will show you convolution in a separate session. But the idea is in this particular architecture, you will go from the picture to a flat vector, again, a linear transformation. And this flat vector will correspond to the distribution. Again, by the way, yes, matrices are very important for neural networks, but at the end of the day, this is still machine learning, statistical learning. So distributions are very, very important.